Our next example asks us to find the limit as x approaches 5 from the right of the function x minus 5 over x squared minus 25. We should always check to see if we can use direct substitution first. Even though we're approaching from the right, if we have a general limit, that would mean that the limit from both the right and the left is the same. Unfortunately, we can't do direct substitution right away, but let's try to do some algebra first. You'll see that our function factors, the x minus 5 stays in the numerator, and the denominator is a difference of squares, so we have x plus 5 times x minus 5. We're able to cancel the factors x minus 5 in the numerator and denominator, so it leaves us with the function, the limit as x approaches 5 from the right of 1 over x plus 5. Because we were able to cancel this x minus 5 in the denominator, that means we have a removable discontinuity when x is 5. Let's see if we can do direct substitution now. If I plug in 5 for x, I will now have 1 over 5 plus 5, which is equal to 1/10. So my limit as x approaches 5 from the right is 1/10. You will find this to be true if you graph this function, and also if you use a table and approach 5 from the right. Let's take a look at our next example. B asks us to find the limit as x approaches 0 of the function the absolute value of x over x. This is asking us for the general limit because it's not asking specifically to be approached from the right or the left. Therefore, we need to have the same limit if we come from the right as if we come from the left. Now, if you were to try to apply the direct substitution method, it's not going to work, and there's no algebra we can do in order to eliminate our 0 in the denominator. So let's make a quick sketch of our graph. Absolute value of x over x should be something familiar to you. Here's my positive 1, negative 1, and we're going to have an open circle here. Whoops. Let's try this again. Going that way, open circle down here at negative 1, and moving left. Okay, that is a quick sketch of what the absolute value of x over x looks like. You will see clearly that as x approaches 0 from the right, our y value is positive 1. As x approaches 0 from the left, our y value is negative 1. Because our left and right hand limits do not agree, they approach two different y values, the general limit as x approaches 0 does not exist.